Solar calculators are pretty neat, right? Those garden lights that charge all day? They use a science trick. It's called the photoelectric effect. What's that, you wonder? It's how light can make electricity. Let's dive into this bright idea. Think of light as tiny packets, little bundles of pure energy. Scientists call these photons. When photons hit certain metals, like zinc or even silicon, something truly amazing occurs. They pass their energy to the metal, a tiny, powerful energy boost. Inside metals, there are tiny parts. These are called electrons. But a photon can change that if it packs enough energy. Bang! It knocks an electron free. The electron is now on the move, zooming off with new energy. So many electrons start moving, all flowing in one direction. Guess what that is called? Electricity. Light hits the metal surface. Electrons are then released. Light making electricity. So cool. Before Einstein, scientists were puzzled by light. They observed light creating electricity. Why did only certain light trigger this effect? And why was it instantaneous? A new way of thinking was needed. It was a scientific puzzle. Then, in 1905, Albert Einstein arrived. He proposed a revolutionary idea. Light isn't just a wave, it also behaves like particles. He called these energy packets quanta, now known as photons. Each photon carries a specific amount of energy. Some photons have more energy than others. A photon needs sufficient energy to dislodge an electron from metal. Light has a dual nature. It can act as a wave, spreading out, or as a particle, delivering a punch. This sparked quantum mechanics, a new field of science. Our understanding of light deepened. Science leaped forward. So how do we use this amazing effect? Look around. It's everywhere. Or those calculators powered by light. It's the photoelectric effect in action, bringing science into our daily lives, making our world work better. Solar cells are the big stars here. They are usually made of silicon, which is a type of semiconductor. When these photons hit the silicon, they transfer their energy, knocking electrons loose inside. These electrons are now free to roam. A solar cell is cleverly designed. It creates an internal electric field. This field acts like a slide. It pushes the freed electrons and makes them flow in one direction. This flow is an electric current. We can capture this current and use it to power things. So, solar cells turn sunlight into electricity, directly, just clean, green energy from the sun. This is incredibly important today. As we look for cleaner power, it's a fantastic use of physics, powering our gadgets and homes. Albert Einstein is super famous, right? Mostly for his E=mc² equation. Actually, he received the Nobel Prize in Physics for explaining the photoelectric effect. This discovery fundamentally changed our understanding of light and electrons. It was a key step for quantum mechanics, the science of the super-tiny, which is the basis for so much modern technology, lasers, computer processors, and medical imaging. Today, the photoelectric effect is more vital than ever. Solar power is a big part of fighting climate change. Understanding this effect helps us build better, more efficient solar cells. So, remember Albert Einstein's brilliant insight the next time you see a solar panel. Those tiny photons knocking electrons free to make power. It's a beautiful piece of science that's still lighting up our future.